computer color coding system. And it's made as a workbook, okay? Interesting enough, listen to this. Code Babies. This is made by a company that writes coding books for babies. Now think about that. When do we start teaching a child to speak Spanish? As soon as they're born. When do we teach them to speak German or whatever language? They learn it usually before they even start kindergarten. So what I'm getting, some places in the world are starting to teach these kids to learn coding, computer information, before they hit elementary school. And this is a book company that thrives on that business. These, by the way, I bought at Barnes & Noble too. If you look there in the book, we're just going to go quickly over that. All this is in the presentations, the videos there. Most of us have lived in the RGB world, red, green, blue, for years. We all probably learned RGB in school and so on. What most of us did not learn, those are called additive colors. What most of us did not learn are what we call the subtractive colors. Anybody who uses a printer today or goes down to buy your cartridges, they're subtractive colors, cyan, magenta, and yellow. So when we were in the photography business and had negatives that were colored, we have to work with the filters of cyan, magenta, and yellow to make skin tones. The hexadecimal system, red, let me think how to say this. A byte, let's go over zeros and ones. In the binary code system, everything is a 1 or a 0. Therefore, that means on or off. You just turn something on. Electrical-wise, you turn it on or off. So it's no longer 1 to 100. It's all 1 and 0, back and forth. So in the color coding system, the way it is for color coding, now not what the average user uses, but if you're into making stuff in the computer, clearly what I'm doing in the microscope or telescope or whatever, you use a hexadecimal system. There are 24, there's bytes and bits. There's 3 bytes, 24 bits, okay? That means you have 888, RGB, red, green, blue, okay? So if you have all ones, anybody know what you have? Or all zeros? All ones is 255. This is hexadecimal now. So the easiest way to do that is get a program for your smart thing that converts. So you put in one, just like a calculator, it's going to put in everything else. So white is all white. Black is the absence of light. So black and white. So one would be 0, one would be 1. But that's not a good way because you have to know 24 ones in a row and all the integrals in between. So this is why they use the hexadecimal system. Okay? And the decimal system if you want to get that high up at that level. Red is 25500. 8 bytes, 8 bytes, and 8 bytes. Okay? RGB. Green would be 0, 2550. Okay? Now, if you translate that into ones, you've got all kinds of ones and zeros strung all over the place. So it's a lot easier for the engineers or us, who everybody wants to do it, to work other than that. Okay? Then, if you go back to our analog world goes from 1 to 100. So we go up and down, right? Your speedometer in the car goes up and down. Now digital, you'll have figures, and it's all ones and zeros. But anyway, you can control these systems in another manner by controlling the power. And I think it involves a lot more into how to control motors and motor control. If you use more than 0 or less than 255, let's say 155, then you're going to get into the shades, the hues, and so on, what is called saturation. Do you all get any of these? What this is for the kids, the children, here's different saturation, hues, and so on, and they can pick up on these and underneath it is a hexadecimal code. So basically, it's a workbook for hexadecimal code for color coding. Okay? So again, I highly recommend it. One principal came to my senior class and she went and bought it for herself a couple Mondays ago. So, anyway, that's it on math. If you think you know math, and if you think by the time the kids are out of school that they're really going to know math for this digital world, more than likely they're not. I don't know anybody is teaching color coding in Killeen. Anybody here in your school learned color coding? Computer color coding? No? Anyway, we'll talk about coding. This is where the coding classes come in. So the next thing in our world is that automation. We talked about macro world, bigger than us now, the micro world, which is smaller than us, and then the next one is what's going to replace us. I worked in a factory when I first got out of high school. Some of the welders there have been replaced in the automobile industry with spot welders, all automation. So, and now we're going to have, by 2020, we're going to have cars that no longer have a steering wheel in them. Like it or not, it's coming. And when the industry decides something, we're stuck with it. In photography, when Kodak came out with the new film and we didn't like it, we had to give up the old film and take the new. So the bottom line is automation. So we're working in two areas compatible with the STEM concept. One is called robotics. So in the field of astronomy, for example, I, from my house, can work a telescope over in Canary Islands, near Spain. That's called remote video. The other is robotics. How do you make something do what you want to do? And what industry is going to do, for example, there's already companies that are replacing humans with this. There's a hotel in Japan already, a test hotel that's not run by humans. It's all run by robots. So when you're checking out a hotel, you're going to talk to the robot, they're going to hand you the keys, walk you up to the room. You give them a tip, I presume. So anyway, the robot kit